All right, thanks everyone for joining today. We want to talk about improving AI agent discovery and execution with a knowledge graph. And maybe a quick question in the beginning. Who's used the knowledge graph or heard the term knowledge graph in the audience? Okay, so that's quite a few people. Then let's start with a very simple knowledge graph first. Oh, what is happening? Okay, let's go back. And let's go here. All right, let's start with a very simple knowledge graph first. My name is Lars, this is Christoph, and we both work for SAP Business AI. And today I will start with the presentation part of this session, and then afterwards Christoph will do a short demo on how to actually use what we present here today. All right, so as I mentioned, we are from SAP, and at SAP, we sell business processes, and the goal is to embed AI in all of those processes. So essentially, SAP Business AI works on embedding AI everywhere in all of the SAP solutions that you can find, ranging from ERP to supply chain and other solutions. And the interface that the user will interact with is called Joule, which is the business co-pilot, essentially, which can automate processes across different solutions ranging from human resources to procurement and sourcing. And in addition, Joule is powered by AI agents that are able to capture context and information across multiple SAP solutions and then automate complex business processes using this information and context. And to give you a bit of an idea of this whole architecture, what this looked like, you can see at the bottom all the SAP applications that you might know, financial management, supply chain management, and so on and so forth, that all produce some transactional data, which you can then bring into Business Data Cloud, our data solution, to then make the data available to Joule that can then use it for AI capabilities. And what I want to highlight here is that at the center between the data and the AI is the SAP Knowledge Graph positioned. And the SAP Knowledge Graph's goal is to translate information for the AI, essentially, to make it more usable and actionable. But let's take a look at the problem that AI agents might face. So suppose you have a Joule user who wants to create a new purchase order for 5 pencils in a certain purchasing group and a certain purchasing organization, as shown here. Now, if you give this task to an AI agent, a procurement agent, and you give the agent access to all of the APIs and services you have in your ERP system, then the agent will struggle to actually fulfill this task. Instead, what we do is we bring in a knowledge graph that provides rich and semantic context about the APIs, the services, as well as the business processes, such that the agent can then execute the task and do it as expected. So what are the two main challenges for the agent? Well, the first one is API discovery, because choosing the correct API, it's not a trivial task, especially in large and diverse system landscapes that we face at SAP, for example. Often the metadata about these APIs that the agent might want to call is partially available only or fragmented across multiple data sources, which requires the agent to then actually go to all of these data sources to find the relevant information. And in addition, these API specifications often include a lot of domain-specific terminology, like acronyms or abbreviations. So for example, in one context, PO is a product owner, but in another context, PO is a purchase order. And to give you an example about the size of the tools or services that the agent can use in SAP, we recently internally released a S/4HANA public cloud knowledge graph, which has 3,500 API services and more than 110,000 endpoints. So essentially tools or services that the agent can call. And the second important part is the business process context, because these APIs, they do not exist in a vacuum. right? But they cannot be called in a random order, just as the agent likes. Instead, the business processes, they determine the sequence in which these APIs need to be called to follow the business process correctly. And these processes can be complex. Business processes also vary for all of our customers. There's no customer that is alike in how they implement business processes. And also the usage of an API may depend on the actual process it is used in. So to give you an example, to create this purchase order that we saw in the beginning, it might be necessary, depending on your business process, to first create a purchase requisition before you can actually create the purchase order. Or in the financial application, it might be required to do some anti-money laundering checks before you can open a new account. So how do we address these challenges? Well, we provide our agent with a set of what we call broad tools. And these tools are to discover APIs. So based on a vector database and the user utterance, we try to identify a set of candidate APIs that might be relevant for fulfilling the given task. For these candidate APIs, the agent is then also able to call a retrieve API tool that retrieves the API specification, this metadata, including business process context. And what you can see here is that this is based on the knowledge graph, and we use also the knowledge graph to generate the embeddings that we use for the discovery in the first place as well. And now that the agent knows which services to call and in which order, based on the process context, it can then call the execute API tool that then actually executes the GET and POST requests over the APIs that you might have. And as you see, at the core of this is the knowledge graph. So what is a knowledge graph? And for all of you who do not know, a knowledge graph represents structured information in the form of a graph. Here you can see that SAP is located in Walldorf, which is located in Germany. Christian Klein is the CEO of SAP, who was born in Mühlhausen, which is also located in Germany. So here you can see that the knowledge graph is represented by what we call triples here, consisting of subject, predicate, and object, SAP located in Walldorf, which are directed labeled edges in the graph, essentially. The nodes, they represent the entities, people, places, or things, but also could be any abstract concept like an API or an IT system. And the edges, they then represent the relationships between those entities. So these are the raw facts that we have in the knowledge graph, but what makes the knowledge graph really powerful is the ontology. So given the fact that SAP is located in Walldorf, we can also introduce an ontology that provides the semantics of the objects and the relationships that we're talking about. So you could say something that SAP is a company, Walldorf is a city. And then you can also introduce hierarchies of these classes. So you could say company is a subclass of an organization, and there could be other organizations like university is also some kind of organization. Or city is a subclass of location, and there could be other types of location like countries. In addition to talking about the entities, we can also talk about the relationships and provide semantics about these relationships. So we can represent the relationship located in our ontology and, for example, specify its range as being location. And that means whenever we encounter a located in relationship in the knowledge graph, we know that it points to something that is a location. And in addition, we could say, for example, that located in is a transitive property. And then by knowing that SAP is located in Walldorf, and Walldorf is located in Germany, we can infer that SAP is located in Germany without this fact being explicitly stated in the knowledge graph. So with these two main key components, these facts and the ontology, we then build our knowledge graph. So what are the layers or the components of the knowledge graph that we build for our business process automation agent? And this knowledge graph is a metadata knowledge graph that has several layers of metadata content. At the bottom, we have the resource discovery layer, where you can bring in information from, for example, Open Resource Discovery or ORD that provides an envelope about the metadata. So it includes which APIs are there, to which systems do they belong to, how are they related to other APIs and, for example, data products. And then, of course, we bring in the API services or tools. So we can bring in information from open API specifications, OData specifications, but also MCP tools could be also integrated into this APIs, services, and tools layer. And as I mentioned before, the glue that connects all these APIs together is the business process. So we also bring in process information into the knowledge graph to connect these APIs and the tools together. For example, using BPMN for business processes or Arazzo for workflows. A second important part that I mentioned in the beginning is that we use the knowledge graph as a data source for creating the embeddings that we use for retrieval. And that's also a key advantage of the knowledge graph because we can use the structure of the knowledge graph to generate these embeddings. And there are various approaches to do knowledge graph embeddings. Often they focus on node classification, link prediction, or knowledge graph completion. But in our case, we want to find the proper service based on the user utterance, based on the user's intent. And so therefore, we use a textual description-based model, which essentially represents a node in the graph by its textual description, but also by the textual description of the connected nodes in the graph. So you can bring in more information from how a node is connected in the graph. And how this works is what Christoph is going to show you now in the demo, and he will also show you how we bring everything together to then build this agent.
Thanks, Lars. Okay, so now let me show you a simple example of how you could build an agent that interacts with business APIs using a knowledge graph. So this is large enough here. Okay, so first I'm going to load a knowledge graph that we've prepared. This contains like 100 toy APIs. And here's a small visualization of it. I mean, what you can see here is basically just 3 of those 100 APIs. Like these 3 clusters correspond to APIs, and then the nodes around them, they describe properties of them, but you also see that there's connections between them, which could be process information, certain links between these APIs that are encoded in the knowledge graph. Okay, and now just as Lars described, the first step in building an agent is we need to take care of the API discovery. And for that, we are going to embed, sort of just to have a first stage of subsetting this large number of APIs that Lars mentioned we have with a retrieval step. And so, like Lars explained, we have sort of use a textual description of sort of the API and its properties. And before we construct that, let's have a look at an example here. So what we have in this particular knowledge graph for APIs, we have a name here. In this case, it's a purchase order API. We have certain links of the purchase order header information to the item level information API. And then these API has properties here, like currency, payment terms, and so on. And each of those, again, has some attributes. That's sort of the data we're working with in the knowledge graph in this example here that we can now use to construct a string that we're going to embed. Okay, and that again is sort of a strength of knowledge graph. We can just issue a query. We can construct it to construct these embedding texts, and it's quite flexible. Sort of we can, like, just by changing sort of to a different query. I mean, here I've just concatenated all those properties and have the API name. You can think, of course, of sort of better ways to represent this if you want, or of other ways. Here I've just changed the query against the knowledge graph, but sort of the basis of my knowledge is in the graph. It stays the same. I'm just extracting different pieces of it for my embedding for an API. Okay, and so once I have decided on a query, I'm going to use the first one I showed. Then I can run this through an embedding model to compute the embeddings. Okay, fine. And what I'm doing here, I'm using FICE. I'm just using in-memory vector database, so I can do my retrieval later. And here I have a function that just queries this, does nearest neighbor search, and with an example utterance here, where the user may ask, like, create me a purchase order for 5 pencils in a certain purchasing organization, and so on. Okay, and then I'm getting back here the top 5 APIs. You see, as you would expect, they have sort of, they look like they have something to do with purchase orders, like this purchase order API here, the purchase order item API. I also see something here about purchase requisition item. And now let's have a glimpse at sort of how this business process may look like. So here, create purchase order has actually a prerequisite step of first creating a purchase requisition. And that is sort of the downside of this vector retrieval here. It may require sort of previous steps that are not semantically similar to what I mean, in this case it is, but it may not be, to what is asked about directly here. So that's why, I mean, we're missing here, for instance, a purchase requisition API. We only got the item level, and so if you would present this to an agent, it would actually not even get all the relevant APIs to execute the process. And so now the question is, I mean, yeah, this is here an illustration of how, I mean, again, what I just told you, like these dots represent APIs. In our cloud here is what we found with our vector retrieval, and we may just hit sort of parts of a business process, mainly the parts that the user kind of asked directly about, but there may be other steps that are required. And that's also what we model in the knowledge graph. So we have this process information, these edges that represent the process, that we can now just use to enhance our plain vector retrieval by sort of completing the processes that we hit with our retrieval, so that we can then present the agent with the relevant processes, but also with sort of the complete set of APIs in the tool loadout to be able to execute the process correctly. Okay, so I'm now doing just that. Here I'm putting in like the APIs that we got, the list of APIs that we got from the vector retrieval, and I'm running this function basically wraps a query against the knowledge graph that gets out all the incoming and outgoing edges that represent processes. Okay, so for our example APIs, we get here just one example edge that points from purchase requisition to purchase order. Okay, and now we can use this to construct kind of an enhanced discovery. So what it looks like is we first do the flat retrieval on the user query. Then for those that we retrieve, we feed them into this query that gets the process information on top. And then in the end, we merge the nodes that we find, the APIs that we find, and then we also explicitly keep the process information, because in the end we're going to show the agent, okay, this is a set of relevant APIs, and these are the processes that these APIs are related by. And then the agent has sort of, the right subset at hand. Okay, so now here I can, let me just run this. Okay, maybe I need to, sorry, forgot to execute this. Okay, no, maybe I need to, okay, hope it's still legible, but sort of the output of all this enhanced retrieval now, it gets you all the APIs we found by the flat retrieval. On top, in our example, we now also get the purchase requisition API, and we get a representation of that process edge that we also retrieved from the graph. Okay, and so with that, we can now actually go ahead and construct an agent. So one thing that I just showed you were, like, for these APIs, we've extracted for the discovery purpose, we just extracted identifiers for those APIs. But of course, the APIs themselves, each of them has sort of specifications that we also need to present to the agent. And that's why we then first run our enhanced discovery. Maybe I can make it larger again. Run our discovery here for the user query. Get here the set of APIs which are identified by some URI in the knowledge graph, and then we basically loop over them and call yet another set of queries against the knowledge graph to fetch the actual specification for each of those APIs. So then in total, the agent will have the right set of APIs with completed processes, and for each it will get their specification, and all of that came out of the knowledge graph. Right, so that's defined, and then I wrap this as a tool. Here I'm using LangChain to build the agent. So then this will be the actual tool that the agent can then call, where it just puts in the user query and then it gets out all this information. Okay, so to build an agent here, I mean, I don't have an SAP system running on my laptop here, so that's why I have sort of mocked functions here. So a mock database for purchase orders. Let's look at the content. So for now, there's just 3 purchase orders in there. Then I have a function here that mocks calling this API here with a payload where I'm creating a purchase order for 5 mice and 3 keyboards. Okay, and then if I call it, I see, okay, these get added here. So this mimics, yeah, creating entries in that database. And similarly, I have a get function here where I can put in a filter string like this, purchasing group equals 005 and purchasing org equals 3000. If I call that, then I would get back just the one record for which this filter condition holds true. Okay, so I have these APIs here, and now I basically simply just wrap them or decorate them here as tools. So the agent will get one tool to fetch APIs, where the input is identifier for the API, service and sort of the endpoint below it, and the filter string for the get API, and for the post API, again, an identifier of the API, and the payload, which is sort of describing the object that it should create in the database. Okay. Now, for the agent prompt, nothing fancy here, so I just describe, okay, first do discovery, then pay attention if there's process information, and then there's some description of how to deal with these header item level relations that we typically see in these kinds of APIs, like some document has header information and then they can have multiple items, couple do's and don'ts, okay. And now I can here define my agent. Again, I'm using LangChain just as an example here. Okay, with that all defined, we can look at an example. So now we can run our agent here on a query where the user asks, show me active purchase orders in a certain purchasing group and purchasing organization. Okay, let's run this. Okay, so what the agent does, it first calls the Discover API tool. That's good. And this tool gets back sort of here with a list of API specs. Sort of this is now a list of APIs, and for each of them, the specs that we retrieved. And then at the end, it also gets back here process information like this, a process edge that could be involved here. For this query, we don't need a process because it's a simple get fetch data query. The agent basically ignores the process information, which is correct. Then it calls the get API here. However, it just calls it with this filter here, purchasing org, on the purchasing org, group and org. But I also asked for active, so something seemed to be missing. And it actually got back 2 purchase orders from our database, which is not what I wanted. I wanted only the active purchase orders. So what I can do now, I can basically enhance, I mean, this is just to illustrate that the knowledge graph is a good place to aggregate your metadata. What you have already, then we can just sort of add on top more context. And in this case, the context that's missing is the mapping here from these textual descriptions of purchase order status to this technical ID here, 02, for instance, here corresponds to active. So now, and this is a query to update the graph. Let me run it, okay? Now the graph should be updated with additional nodes that now describe this. Okay, now I can run the exact same query again. And now, I mean, basically the same happens in the discovery, but except there is now here, it also gets in the specifications this mapping from the description to the technical ID in this case, purchase order status, sorry. And the agent directly makes use of it, because you can see here the filter string now also contains a filter on the purchase processing status. 02 instead of, maybe it could have just, a lesser agent would have just put active or something, but here it uses a correct technical ID, and we also get the correct result, which is just the one purchase order that we had in our database that satisfies all these conditions. Okay, so that is to illustrate, okay, if we have our knowledge graph ready, we can attach new nodes to add additional context that we can use. Okay, so one more example. Now this example that we used already before, create a purchase order for 5 pencils in a certain purchasing group and purchasing organization. Let's run this. Oops, okay. Damn it. Okay, so it runs again first the discovery, basically gets the same or similar set of APIs that we saw before with the process information here in the end. And it correctly realizes it first calls the post data API, but instead of calling like directly the purchase order API, it first calls the purchase requisition API because it follows the process. First create the purchase requisition. Then, this call is issued. Here, the system reflects back, okay, here we have a purchase requisition that got this ID here, and for the line item, it got this ID. And then only as a second step, the agent calls the post data API on the purchase order, where it then also references here the purchase requisition that it just created by an ID, calls that, and then the system reflects back, okay, this has been created. So now let's have a look at the state of our database. So maybe you can make this larger. We see here the last created is as a purchase requisition for 5 pencils. And in the purchase orders, we have also a new purchase order here for 5 pencils, and it links here to the purchasing requisition that was created. So the agent followed the process as we wanted. And that's it for the demo. Let me now get to a summary of what we've shown you today. So I hope we've shown you that the knowledge graph is a good place to aggregate your metadata. So typically you would have metadata in different places, and we use a knowledge graph to link it all together, to make it usable sort of in a harmonized way, and also to benefit from the links that we maintain in there. The knowledge graph provides context for agents, like this mapping of technical IDs that I've shown you. And also, if you want to keep track of where your context for the agents came from, then you can do so by techniques with a knowledge graph, where you can trace back where did this metadata come from, how did it make its way into the knowledge graph, and then to the LLM. So the approach that we've shown you today is like this. I would call it the broad tool approach. Kind of, we just have sort of these 3 broad tools that enable the agent to interact with like thousands of APIs. So it's scalable in that sense. We don't have one tool per API. It relies on the metadata for the knowledge graph, as you've seen. It's also kind of solves the problem of tool orchestration, because you're just a small number of tools. We don't need to sort of overload the agent with like hundreds of thousands of tools, which of course wouldn't be feasible. However, there's also some challenges. Not all metadata is readily AI ready, sorry. So you may lack descriptions, and it's maybe too much of technical IDs that don't make sense without additional context sometimes. So you need to, that needs to be worked on and enriched. This broad-based tool approach, it can have sort of an extensibility problem, in the sense that if you combine it with also more, you cover basically a broad API surface with these tools. But if you then also have sort of very specialized bespoke tools on top of that, then you kind of have an overlap of scope with these tools. And yeah, that's something you need to think about. Yeah, one word on MCP. So of course, these tools you can also wrap in MCP. Yeah, however, like if you wanted to go for a different approach where you have one tool per API, then you have thousands of tools, and you would need to sort of have a dynamic mechanism to scope those tools down, to have a dynamic tool loadout conditioned on the user utterance. And yeah, MCP in its current form doesn't provide a mechanism like that. So that's one challenge you might have with such an approach. Yeah, and with that, thanks for your attention. If you want to learn more about AI at SAP or the SAP Knowledge Graph, follow those links or visit us at our booth. Yeah, and looking forward to your questions.
Thank you, Christoph and Lars. A great look into how providing process information through a knowledge graph makes the context richer and it is smarter. We have time for one or at most two questions. If anyone has a question, please raise your hand. Okay.
Right. Okay. Thank you very much for the talk. So I think what I learned from your presentation is that the beast of your work there is actually the knowledge graph, and also how you would make use of the knowledge graph that you built. And from my experience with using knowledge graph, and my experience is when you have something small and quite fixed as a problem, it's relatively straightforward. But when you have, say, new features you need to add or new nodes you need to edit into the knowledge graph, it becomes more and more hard to maintain in the long term. So I also see you have a embedding model that is basically seems like you retrieve the knowledge graph and convert it in a simple way, not too much semantic to the text itself, but you convert the embedding model to use the embedding model to convert it to vector embedding for the retrieval, a RAG approach. So like how many dependencies you think there are like within this approach, and what would be the limitations of such applications?
You want to take the part on managing knowledge graph?
Yeah, I would start with the managing of the data in the knowledge graph. So as you mentioned, right, it's quite flexible and extensible, but of course that brings a challenge that you can add more and more data to the knowledge graph, and that can then also kind of be limiting for the discovery because then there's so much context. So what we do is we always start with like a core set of information, like especially the APIs and their relationships and the processes, and then as we go, we can extend it more if we understand, if we find what Christoph showed, like there's missing information in the metadata that we need to bring in for the agent to understand the tools or the APIs correctly. Then we bring this in, of course, but we try to keep it at a minimum. And also we can, like as the knowledge graph grows, the way we manage the data in the knowledge graph, we use kind of like subgraphs, and you can essentially, for a specific application or an agent, you can make a certain set of subgraphs available to the agent only, even though the whole graph might be bigger. So for discovery, you could, for example, take a larger graph to do the embeddings, but then during the retrieval of the APIs, you only use a smaller part of the graph.
Yeah.
We have time for one very quick question, if there's one over here.
Right here.
Hi, why couldn't you do this in SQL using standard lots of tables, joins, the classic approach? How does this improve?
Sorry, the question is why are we not doing this in SQL?
I mean, typically you have lots of, in SQL, lots of tables, and you use SQL to effectively create the graph and to do the retrieval. What advantage does this have over SQL?
I mean, one of the key advantages, if you look at it from the consumption perspective, you traditionally have at SAP these tools or Fiori apps that use these APIs to do a certain business process, and then the developer would create this app in a way that it kind of follows this business processy steps. So these tools or these apps already encode kind of the business processes, and already know which APIs should be used and so on. And if you just run raw SQL, so to speak, over the database that is underlying all of this, it's just also becoming way more complex, and it's difficult for the agent to understand how to, like, what it can touch, what it cannot touch, and these APIs already kind of narrow down the scope of what the agent could potentially do with the data, and how also it's intended to be edit or change the data with these APIs.
Okay, thank you.
One big aspect is also, like, in large enterprises, you can have incredibly complex roles and permissions things, and sort of that's baked into typically into layers above the SQL layer. So that's why you want to sort of not skip that.
All right, thank you. We will go for a lunch break, and we will be back at 1 p.m. to continue with 8 more talks on building agents and context engineering.
Thank you.
Thank you.